There is some truth to what the other comments claim. However, the most important limiting factor for your body's ability to use oxygen, VO2 max, is your heart and its ability to pump blood. This is true for everyone except those with lung conditions and elite athletes. On average, we only use 60% of our lungs' maximum capacity when our heart is maxed out. So, to increase our stamina, we exercise our heart. When we exercise our heart, it can pump more blood per contraction. Your heart can pump more blood in GT. More oxygenated blood is pumped into the body in GT. Your muscles have access to more oxygen in GT. Your muscles can maintain a force over a longer time period before producing lactic acid. It is true that the muscles also get better at using the oxygen. More blood vessels are created, more mitochondria, etc. But this is not as significant. This is a heavily simplified explanation and also has to do with lactic acid and proton clearance by the liver, to name an example. Another component of stamina is the amount of hemoglobin in our blood. Hemoglobin is on red blood cells and is what carries the oxygen from our lungs to our muscles. When you do endurance training, your body will respond by making more hemoglobin. The higher the amount of hemoglobin in your blood, the more oxygen you can get to your muscles with each heartbeat. Pro athletes take drugs to increase hemoglobin, or will sometimes do blood doping, where they remove a bunch of their own blood, concentrate the red blood cells, save it in a freezer, wait for their body to replace the missing red blood cells, then re-inject the original blood cells into their veins, giving them a higher concentration than when they started. Your VO2 max is a large part of it. That's the percentage of oxygen your body can process out of each breath of air. If you have more type 1 muscle fibers, that also helps. Some people are born with more, and are thus more equipped to be endurance athletes. You can train both of those and see improvements though. One thing I'm not seeing or maybe missed. The sore/tired feeling in your muscles comes from a buildup of lactic acid. Consistent cardio training not only reduces the rate of lactic acid buildup, through VO2 max gains, already mentioned, but hepatic efficiency at metabolizing lactic acid also improves, this allowing more exertion with the same buildup or reducing buildup for a given exertion level. There are also physical changes. Runners will find more efficient strides. Look at how an Olympian's legs move versus your own. Watch how their upper body moves. It doesn't much. Intercostal muscles and the diaphragm can get stronger, allowing for a larger chest cavity expansion and more aggressive exhale. Some endurance athletes are even able to tap into some portions of the mammalian dive reflex. The spleen can contract and pump excess red blood cells into the bloodstream, allowing for better gas transport. Several things happen when you train stamina. Muscles will grow some, and they'll grow some more blood vessels. Additionally, they'll hold more oxygen and nutrients. Most of this is hardly visible, but you'd certainly feel it. Lung muscles, most importantly the diaphragm, which is basically a funny muscle, but there's other muscles that contribute to breathing, grow, and get accustomed to the demand. The heart might grow some, depending on your age, and it will get accustomed to the demand. Essentially, with practice, it'll learn how to pump more blood. The liver is set to build up carbohydrates to release when they're needed. You learn how to use your muscles more efficiently. This includes how to breathe efficiently while exercising. I'm a lot more of a stamina person than a strength person. I already started with great stamina in my youth, and later extended it to the point where I can walk at a fast pace for a whole day, and the next day, too. Currently, I'm somewhat rusted. For example, I won't start a 100-kilometers hike today. Stamina builds slowly, but it stays a long time, too. Makes sense from an evolutionary perspective. There's two critical components. Your muscles have batteries that can be both used immediately, glycogen stores. This energy is just ready to go immediately if you need to act quickly or do something explosive, but it starts to be very noticeable as you consume these stores. The byproduct of this process can either be converted back into this explosive fuel or it can be directly consumed. But to do so, you have to use the other component. Combustion. You use O2 to blow up fuels and convert it to water, CO2 and energy. The more air you can get your body to uptake, the more you can output. But this part is much less stamina, per se. In theory, you can do this part more or less forever. The two processes can work together to endlessly use and replenish your energy stores to go a bit harder for longer than you could on using O2 alone. But once you cross an unsustainable threshold, you start eating into the energy stores faster than you can rebuild. Soon you start telling your muscles to just go and they just won't. You have to really dig deep to activate even more muscles fibers to make up for the ones that try to work but don't have enough fuel. Some people can or are willing to push harder than others through this, but eventually we all give out. No, it's more that your biology gets more efficient at physical activity via production of specialized cells and set points, so the physical stress is managed well enough to not trigger fatigue and exhaustion. This comment section went from explain like I'm 5 to explain like I'm a 5th-year med student real quick. I'm not a doctor or trainer or anything, but the way I understand stamina is that it basically comes down to how efficiently your body can use oxygen for an extended amount of time. If you use running as an example, the biggest factor that allows you to run for longer periods of time, think marathon versus a sprint, is how well your lungs can break down oxygen and get it into your bloodstream so that your leg muscles can keep working without getting fatigued. You get winded when your body is trying to use oxygen faster than you can take it in, which is what causes people to lose their breath, essentially trying to replace that lost oxygen as quickly as possible. You could also look at stamina as functional threshold power or the max amount of lactic acid your system can remove or tolerate over a given period, perhaps an hour. Glycogen stores during exercise feeding and glycogen recovery are also considerations. The blood running through your body carries oxygen to your muscles. When training, your muscles become more efficient and can function with less oxygen. The out-of-breath feeling when you are running is basically your oxygen supply drying up, so your lungs are burning trying to keep up with the demand you've put on your muscles. The larger the muscle, the more oxygen required to operate. Like the other person said, VO2 max is what it comes down to. The human body is very adaptable to do what it needs to do most of the time. The problem is that you can't just tell your body to get better, you have to do what you can, which results in a little bit of damage. The body repairs itself plus a little extra for next time. If your body is used to sitting on the couch all day, it will get very good at doing that. If you start exercising, your body gradually gets better at it, creating stamina. Stamina really isn't a medical or scientific term, so there's no way to answer. It might refer to muscular endurance, cardiovascular endurance, or a manner of other uses. I would ask a little bit more specific question. TBH, speed juice. You get tired? No. Your blood flow increases and you breath faster to supply your body with O2. People are talking about the VO2 max, which is fine and dandy and all and has effects, but muscular endurance matters a lot. The efficiency of mitochondria in the muscle, the ability to use fat versus glycogen for energy. It's why being a professional cyclist helps a little bit with swimming, but not all that much. You have trained the legs to efficiently do things, but not the arms. Increase stroke volume. Like other commenters have mentioned, it has to do with the heart. Stroke volume is how much blood is pumped by the heart with each beat. This is the same reason why athletes who are in excellent physical condition have on average, a lower heart rate at rest. Your heart doesn't need to beat as many times to pump oxygen to your muscles because it's able to pump larger amounts of blood with each contraction. On a tangent related to stamina, a stronger heart doesn't prevent a person from becoming tired, but it does impact how fast one recovers from being tired, aka stamina. Muscles use oxygen to work. Your blood carries oxygen to your muscles. Breathing air puts more oxygen in your blood. Blood moves in your body through special kinds of pipes, arteries and veins. Your heart is the pump that makes blood move. When you start to exercise your body, the pipes become bigger, and your body creates more smaller kinds of pipes, capillaries. These are near your muscles to directly give them oxygen. When these pipes become bigger, your heart needs to pump less to move the same amount of blood. Your heart becomes more efficient because of the better piping. Your muscles receive oxygen more easily, and your stamina improves. People are mistaken when they say they exercise to improve cardio, heart. They are improving the entire machine of blood and oxygen movement, cardiovascular system. As an example, if you bike to improve your cardio, heart, it won't necessarily improve your cardio, heart, for a different part of your body. For instance, your improved biking cardio wouldn't help you much if you had to use your arms to bike instead. This is because the leg piping system that was improved from biking didn't improve your arm piping. It wasn't your heart that improved your conditioning, it was your piping, vascular. What is even more interesting, the exercise's benefits can be largely very specific. Tests have been done with people exercising cardio by biking with one leg. Their one leg stamina improved as expected, but there was no improvement when they needed to use the other leg. Their heart pumped efficiently with the exercised leg, but the heart was less efficient with the unexercised leg. There is some transfer of stamina from one exercise to another. Running tends to improve a person's stamina in other activities better than with biking or swimming. All common cardio exercises. Most of this information is in the NSCA Fundamentals of Personal Training Handbook. Looked most of the way down and no one mentioned buildup of acid in muscles. I'm no expert, but I believe a person with higher endurance can push their muscles harder/longer. Muscles just literally give up at some point. You will not be able to move your leg with enough strength to actually run, then eventually you will not even be able to stand. I believe it's lactic acid. A quick bing will certainly tell you more than I can. Heart chambers get bigger, so it can pump more blood per minute. Blood gets more red blood cells, so the same amount of blood can carry more oxygen. Individual cells will get more mitochondria, the cell machines that turn oxygen into fuel, making them able to better use oxygen available. Blood vessels grow to the used parts of the body, getting more blood to relevant areas. Other structural changes happen too, like bones, connective tissue etc. all adapt. Muscle cells get a somewhat higher mix of type I fibers that use oxygen for fuel. And last but not least, technique. You'll be able to do the movement more efficiently over time, wasting less energy so your fuel economy improves. Cardio adaptations tend to be a bit more short-lived, so people can lose a lot of their cardio capacity in just a week or two of not training, but it also improves quickly. Someone who's youngish and healthy-ish can go from never runs to can run a marathon without stopping in 6 months. Now this isn't an answer, more an add-on question. Isn't stamina based on sugar stores in muscles too? It's just my faint memories of biology and spars classes, but don't muscles save sugars in some form to use directly? And when all that reserve is used up you can't run anymore and it takes a day or two to get back in shape. Your body becomes more efficient at using things like oxygen and energy, and also you become more accustomed to doing without. For example, the average person can survive with no brain damage without oxygen for about 5 minutes. Elite-level swimmers can go upwards of 20 minutes without oxygen before they start to suffer brain damage. Your body becomes more efficient and better able to cope without.